so now we're going to look at the second derivative, or what's called for multivariable functions, since order and what derivative, which function value I'm looking at matters. And so what we're looking at in second derivatives are what are called second order partial derivatives. This is where the order kind of comes into play. All right, so we had two first order derivatives, right? Two variables, two first order derivatives, right? We had the derivative with respect to x and the derivative with respect to y. The same thing that we did for the first order derivative. Remember, the second derivative is just the derivative of the derivative. All right, well, with multivariable function, I take the derivative of both my first order derivatives with respect to both my variables. And so that means we're going to have 4 second order derivatives. All right, now I'm going to use the rate of change notation and the delta notation, or the function notation. All right, so remember, change in my function with respect to the change in x was the derivative of my function with respect to x, my first order derivative. Change in my function with respect to y was the change in my function with respect to y. All right, so those are my first derivatives, right? These are the first derivatives. And so remember, when we take a derivative, it's the rate of change. And we take the second derivative, it's the acceleration. And so the second derivative is the derivative of my derivatives. Well, because I have two variable parts, there's two ways it can change. And so I'm going to start with my derivative with respect to x. All right, so I can take a second derivative of my function with respect to my x variable twice. All right, that's the rate of change notation, which I don't use that, but the book does, just so you're aware of this means. I'm taking the derivative of my original function with respect to the x variable twice in a row, right? X first and x second. Or I can take a second derivative of my function with respect to x variable first, and then with respect to the y variable. And so this is why the order matters. I'm taking the derivative of my original function with respect to x, then y. All right, and so again, in that order. There's my two derivatives when I take the derivative of the first derivative with respect to x. All right, now I do the same thing with the y. All right, so I'm looking here at my first derivative with respect to y. Take its derivative twice. So again, take my derivative of my function second time with respect to y for a second time. All right, so we're in function notation f sub y, y. That means in that order, I've taken the derivative twice with respect to y and y in that order. Or I could take the second derivative of my function with respect to my y and then with respect to my x. Alright, so that means f of y, x, which means I took my derivative in that order, y first, then x. As it turns out, for our functions, the mixed derivatives here are always going to end up being the same. All right, now we get there in a different order, but the mixed derivative means where I take x then y or y then x. Right? They're actually always going to, when I simplify them, they're always going to be equivalent, and we'll see that when we go through some examples. All right, so I'm going to do a few examples. All right, find the second order derivatives of the following functions. All right, in order to find my second derivative, I need it first. So actually, altogether, I'm going to find 6 derivatives. All right, so my derivative with respect to x first, and then my derivative with respect to y. So I'm going to find my first derivatives and then my second derivative. All right, which actually, this one's not too bad. There are only 2 x parts. That's going to give me 24x minus 52. So there's my derivative with respect to x, and then my derivative with respect to y. Same thing. There's only 2 y parts. So 60y minus 90 is my derivative with respect to y. Right, now my second derivatives are just my derivatives of my derivatives with respect to each variable. So x with respect to x twice, and then x with respect to y. So I'm looking here and taking its derivative with respect to each variable. Well, there's just the one x term, 24x, so the derivative of 24x with respect to x is 24. Now with respect to y, well, I'm looking here, taking the derivative with respect to y. There's no y parts, right? So it doesn't change. This derivative does not change as y changes, and so that's just 0. Alright, there's two of my second derivatives. Done with that one. Now I'm moving here, taking its derivative with respect to each variable. So with respect to y again, and then the mixed y, then x. Alright, so looking at this function, taking the derivative with respect to y, well, the only y part is 60y. So derivative of 60y is 60. And then the mixed derivative is going to come out 0 again, right? Because this one has no, right, I'm taking the derivative of my first derivative with respect to y, with respect to x. There's no x parts, so that zeroes out. And so there are my 4 second derivatives. Alright, so there's all 6 derivatives of that function, first derivatives, and on my 4 second derivatives. Alright, my next example. Alright, x squared y cubed minus 18xy. So again, my first derivatives, and then my second derivatives. Alright, so my first derivative with respect to x, 2x minus 18y. And then my derivative with respect to y, 3y squared minus 18x. Alright, so first derivative's done. Now my second derivative. So I'm going to look here first. Second derivative with respect to x, second derivative with respect to x, then y. Alright, so derivative with respect to x. So again, looking here, taking its derivative with respect to x, well, there's just the 2x, so its derivative is 2. Alright, now I'm going here, my mixed derivative, x then y. So now I'm looking at this function, taking the derivative of it with respect to y. Well, the y part's negative 18y, and so that's negative 18. Right, and so I'm done with that. Now I'm moving on to this one. Take its derivatives. Alright, first with respect to y. So the y part is 3y squared, so that's going to give me out a 6y. And then the mixed derivative is also going to give me out negative 18. Again, if you look at it, that's doing it on a different function, but it comes out the same, right? The x part is negative 18x. When I take its derivative, I'm left with a negative 18. Again, ours will always do that. The mixed derivatives, we get there a different way, but they'll always be equivalent. Right, next example. We actually found this first derivative in the previous set of notes, so I'm actually just going to write it down. If you go look at the previous video, it found this. Alright, so the derivative of this with respect to x was 6xy cubed, and then this simplified to 1 over x. And then the derivative with respect to y was 9y squared, x squared y squared, plus 1 over y. Alright, like I said, we did that in the other set of notes. And so I'm just giving them to you here. If you want to know where those came from, you can go look at the previous video. We did those. Alright, now the second derivative of those functions. Which, before I get started, I'm going to rewrite the 1 over x as x to the negative first, and same thing over here. As y to the negative first. Alright, so I can take my power rule instead of the quotient rule. Alright, now I'm ready for my second derivatives. Alright, my derivative with respect to x twice. So again, looking here, and then my mixed derivative, x then y. Alright, so looking at this function, taking its derivative with respect to x. So the x part's what I'm taking the derivative of, and so the 6y cubed is going to come along as a constant, so 6y cubed, derivative of just x is 1, so it'll be 6y cubed times 1. And then the second part is an x to the negative first, so I get negative x raised to the negative second, and I'm going to leave it that way. If you want to rewrite it as 1 over x squared, fine. Alright, now the mixed derivative. Now I'm taking this function and looking at the y part. Alright, there's just the one y part, the y cubed. Alright, the 6x comes along as a constant. Derivative of the y part, so the y cubed is 3y to the second, which again I'll clean that up. 3 times 6 is 18, xy squared. Alright, and so there are my derivatives with respect to xx, and then x, then y. Alright, now I'm done with that one. Now I'm moving over here, looking at this function, taking its second derivative with respect to y again, and then the derivative with respect to x. Alright, so first, with respect to y, so I'm looking at my y parts. The 9x squared comes along. That's a constant. Derivative of the y squared will give me 2y. And the derivative of the y to the negative first will give me negative y to the negative second. Again, I'm going to clean this one up. 2 times 9 will give me 18, x squared y minus y to the negative second. Now I'm fine if you leave it y to the negative second. If you want to rewrite that as 1 over y squared, rewrite it. Alright, one more to go. The mixed derivative with respect to y then x, which should come out the same as this one, but we do get there in a different way. Alright, because I'm looking at this function up here. Taking its derivative with respect to x, well, there's just the 1x part, which is the x squared. The 9 and the y squared come along, so 9y squared are constants. Derivative of the x part is 2x, right? So this step is different than this step, but when I simplify 2 times 9, I do get 18xy squared. So they do come out the same. How we got there was different. Right? But when they simplify, they always will simplify to the same. Alright, the next example. Alright, so first derivatives and then the second derivative. Alright, so f sub x, f sub y. Alright, derivative with respect to x. So the x part's what I'm taking the derivative of, so the 4 y to the fifth comes along. Derivative of x cubed gives me 3x squared. Minus 3 plus, I'm taking the derivative of the x to the fourth, 4x cubed, the y squared comes along, 2 is a constant. And so I am going to clean this up since I know I have to take a second derivative. So 3x squared times 4 will give me 12x to the second, y to the fifth, minus 3 plus 4x cubed, y squared. Alright. There's my first derivative with respect to x. Now my derivative with respect to y. Y is a little easier. Not a lot, but a little, right? Because this will zero out, that'll zero out. And so I take the derivative of this one with respect to y. The 4x cubed comes along. Derivative of 5y is 5y to the fourth. Alright, zeroes out. X to the fourth comes along. I take the derivative of y squared, right? That's the part I'm taking the derivative of, which is 2y. Again, I'm going to clean that up before I go to my second derivatives. 20x cubed y to the fourth plus 2x to the fourth y. Alright, there is my first derivative with respect to y and with respect to x. Just going to kind of double check real quick before I go on to the second derivatives. Alright, looks good. Now my second derivatives. Alright, so again, first here, with respect to x twice. So I'm taking the derivative of the x part. The 12y to the fifth comes along. Derivative of x squared is 2x. Negative 3 zeros out. The 4y squared comes along. Take the derivative of the x cubed, which is 3x to the second. Alright, clean it up. 24xy to the fifth. 12x squared y to the second. And there's my second derivative with respect to x twice. Alright, now my mixed derivative. So now I'm looking at the y parts. Alright, so the 12x squared comes along. I take the derivative of 5y, which is 5y to the fourth. The negative 3 is a constant. Zeroes away. 4x cubed comes along. Y squared gives me out a 2y. Clean that up. And there's my mixed derivative. Alright, so 2 of my derivatives down. 2 more to go. Alright, so I'm done with this side. Now I'm moving on to the other derivative. Derivative with respect to y, each of its derivatives. Alright, derivative of the y with respect to y again. So again, it's the y parts. 20x cubed comes along. Derivative of y to the fourth is going to give me 4y cubed. Alright, derivative of 2x to the fourth y. So 2x to the fourth comes along. Derivative of y is 1. Clean that up. We get 80x cubed, y cubed, plus 2x to the fourth. Alright, done with that. Now the last one, the mixed derivative. Should simplify to the same as this. Excuse me. Alright, so taking the derivative of this with respect to x, so now I'm looking at the x parts. Alright, so the 20, y to the fourth comes along. The derivative of x cubed gives me a 3x to the second. Plus the 2y comes along. The derivative of x to the fourth is 4x cubed. Alright, when I clean it up, it should look exactly like the last one. I get 60x squared, y to the fourth, plus 8x cubed y, and it does match with the other one. Alright, so there are all 6 of my derivatives, right? My first derivatives and my 4 second derivatives. The last one. E raised to the 4x squared minus 2y, if you can't read that. For some reason, and that one's a little blurry. Alright, so the first derivatives, and then we'll get to the second derivatives. Alright, so chain rule. Alright, derivative of my e function is my e function times the derivative of the inside with respect to the variable. Alright, so first with respect to x. So I'm going to get an 8x to the first. Alright, so there's my derivative with respect to x. And now with respect to y. So e first times the derivative of the y part, which is a negative 2. Alright, the negative 2, it's up to you if you want to leave it like that or you can rewrite it. I think it's easier if they're rewritten with the e term last. So I'm going to rewrite it, but again, you don't have to. 8x times the e term, and then f sub y, which is negative 2 times the e term. Alright, now the respect to each of those. Alright, the derivative of them with respect to each variable. So f sub x, which is going to require my product rule, right? Because I've got an 8x, which is one function, and the e with an x squared, my second. So I am going to have to use the product rule. 8x is my first, e is my second. Alright, so it's my first times the derivative of the second, which again is just going to give me out another 8x. Might need a little more room than what I gave myself. Alright, this is the derivative of the e term, right? Which again is that same expression I get up there. Alright, plus the second times the derivative of the first, which is 8. Alright, so it's up to you. You can leave it or simplify it. I'm going to simplify it just because I think it's good practice. So I can pull out an 8 in the e term. When I do, I'm left with, I pulled one of those 8's out, so I still have 1, and 2 times, or x times x. So 8x squared is what's left when I simplify. And in the second term, I pulled everything out. When I pull everything out, there's still a 1 left over. Alright, so there's the derivative with respect to x simplified twice. Second derivative with respect to x twice. And now my mixed derivative with respect to x, then with respect to y. Alright, this one won't require my product rule because the only y part is up here in the exponential, the negative 2y up here. 8x is just a constant, just like that negative 2 over here is a constant. And so 8x is going to come along. I take the derivative of the e part with respect to y. Well, the derivative of the e function is the e function with respect to y, which means I take the derivative of the inside with respect to y, so I'm going to get a times negative 2. And so if I rewrite that, that's negative 16x times the e term. Right, and there's my mixed derivative. Alright, 2 more derivatives to go. Alright, so I'm done with my derivative with respect to x. So now I'm looking here with my derivative with respect to y and taking the derivative with respect to y twice, and then the mixed derivative y then x. All right, this one's a little simpler since negative 2 is just a constant. It's going to come along. And so it's going to be negative 2 times the derivative of the e. Well, the derivative of the e is itself. Times the derivative of the inside with respect to y. So I'm just going to get another negative 2. All right, if I simplify that, it becomes 4e. So there's my second derivative with respect to y. All right, now my mixed derivative will turn out to be this. Now I'll get there in a different way because the first thing I write down is my 2, negative 2e to the 4x squared. And for some reason I changed that to a 4 up here. Make sure that's a squared. Minus 2y. And then the derivative of the x part, which will give me an 8x. So again, I get there in a different way. But when I simplify, it simplifies to the exact same thing. And so there's my mixed derivative, negative 16x e raised to the 4x squared. So make sure you change that to the 4x squared minus 2y, and there are my derivatives. All right, so we'll finish there. All right, so this is where this one was a fairly long one, but it was really practicing the same concepts. We're just doing a bunch of derivatives, right? I find 2 first derivatives and 4 second derivatives using the same process that we did in the last section. It's just taking a bunch of derivatives. All right, first order and second order. All right, so we will stop there.